we're going to talk about time. But we have a lot of problems with time because it's really gotten out of hand for the last 100 years. We have no idea what time is, but it turns out all these people like Einstein and so on, they have this notion that space-time is something that you warp. These four number lines, in fact, they never show you four number lines. They always show you two, and they bend it into a third dimension. That's what they show you, right? And one of those is time, so they warp time and they say that's gravity, what you're staring at there. Okay, so we have a problem there. I like to say space-time is a waste of time, total waste of time. Don't even bother worried about space-time as far as physics is concerned. We don't care what they do in mathematics, but in physics we have no use for space-time or for time for that matter, okay? No use whatsoever for them. Where did we get all this stuff about, time dilation and time travel and twin paradox, all this nonsense that they came up with in the last 100 years, especially Einstein, who try to make sense of all that? It starts with this fellow. His name is Woldemar Voigt, okay? And he came up with this factor, 1 minus v squared over c squared. He's the guy who, as far as I can tell, he's the first guy to come up with that. And so he has this factor, okay, and he was working on the ether. He was trying to explain to some degree, right, again, the null hypothesis, the null results of the Michelson-Morley experiments. They did several. Okay, so he was trying to explain that to some degree, and so he came up with this factor. And there were a couple people. One was Oliver Heaviside, and together with Fitzgerald, another mathematician. And he said, in other words, he was trying to save the ether. He said, no, hold it. Michelson and Morley have to be wrong. There's got to be an ether out there, right? And he said, so what happened? How come he had these null results? And he said, oh, I know. And he says, in order to save the ether and explain the Michelson-Morley results, Oliver Heaviside theorized in 1889 that magnetic fields, he was working more on the electric side, right, deform in the direction of travel during motion, and that this pancaking, accumulation effect, right, of electromagnetic fields was responsible for the contraction. And so what happened? Well, he talked to Fitzgerald. They talked quite a bit, and they discussed that. And Fitzgerald took that, he borrowed that, and he came up with he didn't come up with a factor. The guy who came up with that was Lorentz, right? He came up with a factor, but they worked it out in such a way that using that factor, they could talk about time dilation. Now, it was time that was, expanding and contracting. And you say, what the hell are they talking about? What do you mean time is expanding and contracting? Is this physics, or or is this the Twilight Zone? What is this all about? And so, they took this. Einstein came a little bit later, and he took this and he came up with this notion that if you put a mass in there, it weighs space-time downwards. And eventually all the mathematicians bought into this. What they were doing is warping the number lines. And the question is, does this make any sense? For a concept known as mass, which is not a physical object, mass weighing down number lines, supposedly 4 number lines, which they replace 3 of them with the word space, and they say, well, this is space, and the other one's time, whatever that means, right? And so they have this, Descartes coordinate system, as they call it, but it's really just number lines. It has nothing to do with dimensions or coordinates or vectors. It's only number lines. They're going to weigh this thing down, which they replace with a net, fish net, trampoline, canvas, whatever you want to call it. And they're going to weigh it down with this concept called mass. So does this make any sense so far in physics? Absolutely not. And it's not my opinion. It's that it's just self-evident. What you're seeing is garbage. That's what you're staring at, just pure unadulterated garbage. Okay, and so what Einstein did next, he put the Earth on top and had the moon roll around it. He really did it with the sun and Mercury, right? He wanted to explain the orbit of Mercury. Okay, so this is their notion. This is what we have today. This is the reason this pencil falls. According to them, it's because, the space here is warped. That's why you fall, because the space underneath me has got a hole in it. That's why I fall. So why do I fall downward? Why don't I fall upwards? They've never explained that. I mean, isn't there space-time upwards also? I'd like to know that. They never draw it upwards. They always, because if they drew it upwards, people would say, well, that's counterintuitive. But if you do it downwards, nobody questions it. That's essentially what it is. And so what's the issue? The issue is none of these people, because it all comes down back to language, the jargon these people have invented, a totally irrational jargon where they have all these concepts such as field and energy, and they just throw them around like, you know what I'm talking about. I'm talking about energy. Oh, yeah, energy, I know that. And nobody has any idea what energy is. And so let's begin there. They have no definitions for any of these words, but they use them liberally like if you knew what they're talking about. Like, you know what I'm talking about, right? No, I don't. Please define. And here you have the first word, energy, and good old Richard Feynman, he comes to the rescue again. He says, it is important to realize that in physics today, we have no knowledge of what energy is. Yeah, and when good old Dicking did not understand is energy is not a what? Energy is a concept. There you have the definition, the ability, the capacity. That's what the word means. So it's defined as a concept. It's not defined as a what, not a thing. And here we have another version of that. Okay, energy is difficult. This is from the AI, by the way. Energy is difficult to define because it is an abstract concept. Yeah, it's a concept rather than a what? Concrete object. And yet, they illustrate it. That's not my illustration at the bottom. I'm just putting that on there. They illustrate it as something like a smoke of some kind that's got rays and blah, blah, blah. Who knows? Very, very impressive images. Is that what energy is? Is that what it looks like? Like, all these lights, all this smoke? Is that what fog, whatever? Well, defined as the capacity to do work, energy is a useful mathematical quantity. It's a quantity, right? But it is not a tangible thing itself. Now, how do you explain this to 99% of the public out there who think that energy is a physical object, partly because they pay for it every month? Yeah, they're not receiving any physical object. They're receiving energy. And what is energy? Well, it's a bill. That's what energy is, just a bill. That's the only tangible part of energy. Okay, and you say, well, but energy runs my lights and my computer. And yeah, again, you need to explain. You need to tell me what energy is, what you think it is, and using that definition, that notion that you just put forth, with that now you have to explain what turns my light on. That's the way it works. You can't just say energy does it. Well, you haven't told me anything. You could have said X, or you could have said, spirit did it. Energy is just another word for spirit. It's a modern spirit, okay? Not the old energy spirit like an angel or a spirit. Now, these are genuine spirits, number spirits. Okay, so here there was a reason. This is a fellow on, this is interesting because this was a fellow on, the Stack Exchange. And he eventually he stopped being a physicist, stopped studying physics because he just couldn't take it any longer. And it's interesting why he quit, and it's got to do with this word field, another famous word of mathematics. There was a reason why I constantly failed physics at school and university, and that reason was that I mentally refused to believe, right, more advanced stuff until I understand the fundamentals, which I eventually never did. Right. One of the most fundamental things in physics that I still don't understand a year after dropping out from the university is the concept of field. No one cared to explain what a field actually is. They just used to throw in a bunch of formulas and everyone was content. And so this is a notion they gave him. I guess he got it out of a book or whatever. It says, an electromagnetic field is a special kind of substance. And it continues, right? And he said, what? A special kind of substance? Are they for real? This sounds like the authors themselves didn't quite understand what a field is, so they decided to throw in a bunch of buzzwords to make it sound right. And I hope you already see why I hate physics. Absolutely, and he's wrong. It's not physics, it's mathematics. If he would have known that what he was doing is not physics, he would have probably been more correct. But here we have what he was told, or where he ended up with this. Is a field material? Apparently it isn't. It doesn't consist of particles like my laptop or even the light. Is a field not material but still real? Or it's just a concept that helps us to explain our observations? And his teacher told him a field is a function, right, that returns a value for a point in space. That's what a field is, just a function, a number, a value, etc. I can't understand how mathematical functions can be a part of the universe and shape the reality. Yeah, they're using concepts, and so, what you need to understand is a field is not a physical object, it's a mathematical concept. And it takes a long time for a lot of these people who've been brainwashed to exhaustion to understand that energy and field cannot be used in physics because both of them are concepts. We do not move concepts around in physics. That's okay in poetry, in ordinary speech you can get away with murder. Love moved mountains? Absolutely. And over there, don't say that love moved mountains in physics. Likewise, you can't say field did this and energy did that, not in physics. You can't use those words as physical objects. That's the whole issue. And, 99% of the theories are based on those two words. You can't live without them in mathematical physics. And what are they? Numbers, concepts. Okay, so Einstein gave his best shot at defining the word time, right? Because, again, we don't have a definition for energy. We don't have a definition for field. And no one's got, even to this day, a definition for time. What is time? What is this famous word that we use, that we dilate, that we travel through, that we can go back to the past and come back when one twin gets older, the other one less older, and so on? What is all this? What is this thing called time that affects us so much? And so Einstein came up with this. He said, in mathematics, he didn't use exactly that word, okay? Time is defined by its measurement. Time is what a clock reads. That's what we get out of the Wikipedia today. Time is what a clock reads, what a clock measures. I don't know. My clock doesn't read anything. I have to read everything myself, the newspaper, all that stuff, because my clock doesn't read. What does a clock read? What are you reading? What are you measuring? And that's what they can't answer. And so to say that it reads X, you can say anything for that matter. And there, you have time travel, all this stuff that they invented today, which has nothing to do with physics. None of this has any reality whatsoever. Okay, traveling to the past, traveling to the future, which is the same thing, by the way. Okay, because if you can travel to the future, you should be able to travel to the past. And they say, well, we can travel to the future, but not to the past. Well, go ahead and try it. Because it's mentally we can all travel to the past and say, oh, yesterday I talked to Julius Caesar. Oh, okay, you're one of those, huh? But so we would treat them like a nut. But traveling to the future, well, we don't have the technology yet. That's what they would tell you. So they can get away with that for quite a while. Okay, so here we have a little more formal definition from the Wikipedia and the dictionary for the word time. What is time? And according to the dictionary, the indefinite continued progress of existence and events in the past, present, and future regarded as a whole. Whatever that means. And what do we see in the Wikipedia? It says, time, the continuous progression of existence that occurs in an apparently irreversible succession. Even that's been overruled. They can now do it in reverse as well, right? Negative time, right? Succession from the past through the present and into the future. So we have to look at these three words that both definitions have. Past, what is it? The set of all events that occurred before a given point in time. Okay, so they use the word time to define past, and they use the word past to define the word time. Love it. Present is the period of time that is occurring now. Okay, what is that? You look at now, the present time. Absolutely love it. So the present is the now, and the now is the present, and both of them are time. Great. What's the future? The time after the past and present. Okay, we learned a lot with all this. Yeah, we have no idea what past, present, and future are because they're defined as time, and time is defined as past, present, and future. Great. So we have synonym, we have circular definitions, and they say, well, you can't define any word precisely because you need words to define words, then you need to define those as well, and those as well, and those as well, ad infinitum. So we have a problem because these people don't understand what a definition is. No one defined what a definition is in the last 10,000 years, right? And that's why we have no definition, no scientific definitions of any value today. That's where the problem is. That's the first thing I had to attack. Definition. We needed to get the language right. If you're going to explain your theory to someone, you should at least have your definitions, down pat. Okay, so here we have one fellow who, because of all this, he concluded something irrational about time dilation. And his name is Don Lincoln. He's from Fermilab, so I guess he's an authority, right? He's on the internet, anyways, and he represents Fermilab, so I guess that's as authoritative as it gets. So listen to Don Lincoln. He'll tell you exactly his version of time dilation. Here it is.
They both agree that the remote person's clock is slower. Observer 2 sees more time elapsed than Observer 1 sees at Observer 1's location, but sees less time elapsed than Observer 1 sees at Observer 2's location. This is a super subtle point, but it clearly says that comparing clocks between two moving observers is a tricky business.
So after 100 years, no one has any idea what time dilation is. Time dilation means that you're standing still and I'm moving, right? Could be at any speed of light, whatever, right? And you say, okay, your time is going slower and my time is going faster. But you're moving with respect to me, right? And so you're going in the opposite direction. Are you moving? Aren't we both moving? And they never figured this out. Einstein especially, he never figured this out. And so let me prove it to you. Here's proof for you. I had a talk with God Almighty himself, the all-powerful man upstairs. I had a talk with him, and we bet a beer, okay? And I said, I can move you. You're not all-powerful. You're not as powerful as you think. You can stand still, whatever, but I'm going to move you. And he said, oh, yeah? And he bet me the beer. And so, so here's good old God, he's up there in the sky in space. And he said, okay, this is what I'm going to do. I'm going to sit him completely still. And he just pointed and stood there still, completely still. And I had to move him. How was I going to move him? And so I did the following. I just took my little finger out and started moving my finger. And I moved him. And so I said, give me my beer. I won. What do you mean? I stood still and you didn't move me. I said, what do you mean I didn't move you? Look, I can prove it to you. I filmed it, And here it is. Where is it? I missed one. I guess this one's it? Yeah, that one. Sorry. So I showed him that the distance was changing between an atom in my finger and an atom in his big toe. So I proved to him that the distance is changing. And if the distance changes, location changes. And so his toe is moving with respect to my little finger. I moved him. And he finally conceded and, had to give me my beer. I did win that beer fair and square, I was able to move God. And so the question is, if you ever want to prove to someone that you're more powerful than God, he can be all powerful, but he can't stand still if I don't want him to stand still. I'll move my little finger, and he's got no choice but to move with respect to my finger. He changes his distance with respect to it. And this takes us, we need to get through these definitions. This takes us to this. We need this set of definitions to find out what time is. And in objects, that which has shape, space is that which doesn't. Okay, we have the something and the nothing. Okay, they're antonyms. So now we can use these two words consistently. What is distance? Well, it's a separation or space between two objects. Okay, and what is location? It's the set of distances from one object to all the rest in the universe. And now we can define motion, two or more locations of an object. Okay, so now we know what motion is. So if I want to fight God and say, hey, I moved you, all I have to show is that the distance between my little pinky, right, an atom, and his pinky or his chest or his eye or whatever, change distance. If it changed distance, change location. If it changed location, you have two or more locations, you have motion. He moved. I moved you, whether you liked it or not. Okay, so it's done by definitions. We have to respect the definitions, and that's why definitions are very important in science. And so what is time? And we have to disappoint some people out there because first thing we say is physics has no use for time. We don't use time in physics. Time describes, physics explains. Physics does not have any use for time whatsoever. Time is a measurement. Physics is not about measurement or equations, which are simply descriptions. Okay? We need explanations. And that's why time has no place in physics. The role of physics is to provide physical interpretations for how, meaning why, cause, mechanism, the universe works, causes and mechanisms. Where motion is out there, time is in here. Okay, so time is in your brain. Why? Because time requires memory. Time requires an observer. You can't do without an observer if you're going to talk about time. When there were no humans on Earth, assuming we are the only living entities in the entire universe, when there were no living entities on Earth, there was no such thing as time. All there was motion. Motion was out there. Things were moving. We don't have to have an observer to have motion. Simply have to change location. Time, on the other hand, you need memory. You need to record the previous location of something, the previous motion of another thing, and compare yourself against it. And so time requires someone to make a comparison. What is a comparison? A comparison between two motions. That's what time is. The second hand on, this is an example, the second hand on your watch moves one tick mark while the Earth travels 30 kilometers around the sun. Okay? That's a comparison that living entity makes. This is just one example. You want to see a cheetah run, you got to compare that motion against something else. For example, if you have the cheetah out there in the universe, or an elephant or whatever running out there, if it's just like that, there's no motion. And you say, well, it's moving its legs. Yeah, but it's moving its legs with what? With respect to the other legs, or with respect to his body. So now you have two things, a motion of a leg versus the motion of another paw or whatever, right? So for there to be no motion whatsoever, the cheetah or whatever animal has to stand completely still, and then there is no motion because you have nothing to compare it with. If the cheetah floats, you wouldn't know it, not in space in the middle of nothingness. The only way is comparing it against something else and say, okay, this is moving this way compared to that one. Now you can start your clock. You can say, well, there's so much motion between them. You record that motion, watch the movie, and you say it moved. And it moved in so much time because I created a standard, the second, the minute, the hour, whatever year. And so, yeah, you need two motions. That's what time is, a comparison of two motions.